In this session I want to talk about the internal rate of return. Now in a separate video this was seen as a highly complex calculation, and it involves normally higher powers in an equation. So for example 1 plus I to the power of 4 or to the power of 3 or whatever the time period is. And mathematically it's extremely difficult to solve, and the best way to approach it is by what we call iteration, by trying out figures to see if they work. And in this session I'm going to do just that. I'm using a spreadsheet, I'm using an Excel spreadsheet, and we're going to try and solve a problem in the internal rate of return in that calculation, trying to solve the problem using this process of iteration. So let's see how it works. Now let's say we have the cost of the asset, which is right now, this in the current time period. Then year 1 we have a flow of returns to the asset, year 2 a flow of returns, and year 3. We won't complicate it with disposal of the asset or scrap value. We'll just keep it very simple. But here we have 3 time periods. So we're talking here about a cubic equation. So to solve a cubic equation is extremely difficult. So we're looking here to use the spreadsheet to give us a solution instead of going through straightforward mathematics. Now just for argument's sake, let's say we've got a £4,000 cost, 3,000 or 1,500 and a 900 returns. So just say that that's the cost, those are returns over 3 years. And we want to calculate the internal rate of return on the asset to see if it's worth buying. Once we've calculated the internal rate of return, you'll remember, we compare it with the cost of borrowing, let's say the rate of interest. Now, the way to do this is to discount each of the years by some figure. So let's say we've got 3,000 divided by 1 plus I to the power of 1. Well, anything to the power of 1 is just the same thing. So it's 3,000 divided by 1 plus I. We can forget the power of 1. The second year is 1,500 divided by 1 plus I squared. And the third one, 900 divided by 1 plus I to the power of 3 cubed. So we need to find a value for the i's in here. Well, they're all the same value, but we need to find a value for the I which will equate these two sides, and that will be our internal rate of return. So you can see if we try to solve it, we'd have to multiply each side of the equation by 1 plus I cubed. So we'll multiply 4,000 times 1 plus I cubed, which is just 3,000 times 1 plus I squared, because this one here divides it, plus 1,500 times 1 plus I to the power of 1. This one here. And this one here is just 900, because we've multiplied by 1 plus I cubed, so those two would cancel. So we need to find a solution to this equation, and as I said, it is complicated. So using the computer in this way is a pretty good idea. Let the computer do the work for us. Now what we're going to do here is we're going to take the left hand side, this side over here, equal to the right hand side, or HS, the right hand side over here. Now if we can get the left hand side to equal the right hand side, that's it done. So we need this left hand side to equal the right hand side. Now, the left-hand side, well, here I'd refer back to the formula part of the spreadsheet. Here we've got 4,000 multiplied by, the little star means multiplied by, 1 plus D9, D9 is a cell number, raised to the power of 3. That's what the little upward pointing arrow here means, raised to the power of 3. Now D9, well, D9 is this figure here. So the left-hand side, the left-hand side of the equation here, this one here is 4,000 times 1 plus D9, 1 plus D9, 1 plus 0.5, raised to the power of 3. And if I is 0.5, that's the figure we get on the left-hand side. Now on the right-hand side, you can see here it's 3,000 multiplied by 1 plus D9. Remember, D9 is here. So 1 plus D9 raised to the power of 2 squared. And there's the formula there. So it's 3,000 times 1 plus D9. D9 is I. That's the value we're giving it, squared. And we just read on. It goes plus 1,500 into, or multiplied by, 1 plus I to the power of 1. In other words, 1 plus I. And there it is there in the formula. And the last one is plus 900, which is just there. So if I, or D9, is 0.5, the right hand side is 990. So there is a balance. It's, in other words, this figure here is not very accurate. Let's try a different figure. Let's say instead of 0.5, let's make it, we should really make it half the figure. When we're iterating, we tend to go for half figures, half the differences all the time to try and get it down. So we should make it 0.25, but let's just bring it down slowly just to see what it looks like. Say it's 0.4. Now you see, the figure here is better. It's 2,096. It's moving in the right direction. So it's not 40%. As I said, we should really halve it, so the next one I take should be 0.2, but I'm just going to take 0.3 to see how it comes down. There, it's down to 868. So the two sides are getting close together, and we're on 30% here. Let's take 20. Overshot, because now it's minus 108. It's very, very close. So it's a bit more than 2. So let's make it 2.5. 350. So it has to be less than 2.5. 2.2. 2.2 is good. 68. So the difference between the two figures is 68. 2.2. Let's go 2.1. 2.1 is too small. So it's 2.1, say 5. 23 again. 23 is not bad. We could live with that. We could say that the internal rate of return is 21.5%. Now, if you can borrow the money for 10%, and get a return of 21.5, then obviously investing is a good idea. So what this technique has done is enabled us to iterate, to try out different figures here, to try and get the two sides to balance. We can live with something like 23.8. That's an error. But if you really had enough time and you want to sit down and really play with this figure, you might have 21.45 something something or whatever. You will eventually get to a figure where this is 0. But just for the moment, 21.5 is fairly close. It's almost there. That's almost correct. So that's how you would use a spreadsheet to calculate the internal rate of return. The trick is entering these formulae that I've set up here. Just getting those correct, those two formulae, the left-hand side and the right-hand side, and then getting a figure that balances the two of them, to makes the equation here, makes that left-hand side equal the right-hand side. And 21.5 seems to be the figure, or thereabouts. And that's it. That's all I want to do in this session. So thank you for watching.